In this goal, you need to know accuracy, precision, and percent error. Let's start off with some definitions. First of all, accuracy. Accuracy is how close a measurement is to accepted or true value. So this could be a value that you look up in a book. For example, if you look at the density of gold is around 19 grams per cubic centimeter, and you would compare your sample of gold, take the density, and see how close it would be to that standard value that you would look up in the book. So in this first target here, because it hit the bullseye, we would say it has high accuracy, and in this second one, we say it has low accuracy because it didn't hit the bullseye. So we have some error involved between the bullseye and where the target hit. Precision. Precision is something totally different. Precision is how close a set of measurements agrees with each other. So you would have a set of shots, not just one, a set, and you can compare how close they are. So right here we see on this target has very high precision because most of these shots were very close to each other, but you could see that it didn't hit the bullseye. So we would say that the accuracy is poor, or low. Let's look at these three targets and just kind of look at precision accuracy. Let's look at this first target. This first target, we see that there are three shots and they're very, very close together and they agree with each other. So we would say it has high precision. However, it is off from the target. So we would say it has low accuracy. Let's look at the middle one. This one has good precision and good accuracy. So it hit the bullseye and they're close together. That's what we want. And this last one, we have both poor accuracy and poor precision. So it didn't hit the target and nothing agrees with the other one. So let's get a little example. Let's say you got a job at a pizza shop and you were told to make a pizza this size here. So in your first attempt, here are your 4 pizzas that you have. So what can you say about your accuracy and your precision? Well, as far as precision, you're pretty good. Look, they're all pretty close to each other. But accuracy, you are not being accurate. The customer is not going to want to get these pizzas when they want this size. So you try it again. On the next 4 pizzas, look at this. Okay, so how are you doing? You're doing better. This one's a little small. This one's a little big. I think we'd all want that one. And these 2 ones here, we can say that the precision is actually pretty poor here because it's not all the same, but your accuracy is improving. So that's good. And as time goes by, you'll be able to get the pizzas rolled out to the correct size. All right, let's go ahead and do a chemistry example. So let's say you have a beaker and you put it multiple times on electronic balance and we get 4 values there. So you have 151.5, 150.3, 150.9, 149.9. And for the accuracy, you're told the true value of what's in the beaker is 165 grams. So let's go ahead and look at precision and accuracy. So with precision, you would look at the difference between each beaker. And you can see your low value is 149.9 and your high value is 151.5. And really for an electronic balance, that's way off. So you would say you have poor precision. Maybe you need to recalibrate your balance so that you can get more precise readings between your sets. They should be pretty close, within maybe 0.01 grams even. The balances in our lab, they're really precise. So you should, if you put the same beaker on multiple times, you should get about the same number. So we see that something's going wrong here, maybe with our equipment. The true value of the beaker we see is way off for what that we have for any of those different measurements. So what can we say about the precision and the accuracy? You'd say it's poor for both. So on the test, I will give you a set of data, and if it's really, really close, like within 0.1, you can say it's precise. And the accuracy should be pretty close too. So here we have a case where this is neither precise nor accurate. You also need to know how to calculate percent error. Percent error is this equation that's shown right here. So percent error is equal to the absolute value of the theoretical minus the experimental divided by the theoretical, and you multiply that 100 by 100 to get a percent. And what I mean by theoretical, that's that true value that we've been talking about, or the known value, or the actual value, some sort of value that you're told that it should be, or you looked up in a book. So let's go ahead and do a problem where we figure out the percent error. So we have the student measures the mass of a piece of copper to be 6.03 grams and the actual mass is 5.8 grams. What is the percent error? So when we figured this out in that formula, the value you're supposed to get appears twice. So this is the percent error that we're figuring out. So we take the absolute value, and absolute value, it just means if you end up getting a negative, just to make it positive. So what we should get appears twice. So the difference between what you should get minus what you got, and divide by what you should get, and again multiply by 100. So plugging this into the calculator, we get 5.8 minus 3.03 equals divided by 5.8, and ignore the negative, times by 100, and I get 3.97% error, which is pretty good. In chemistry, if we can get below 5% error, that's pretty good. I would be happy with that. So obviously as close to 0% error is the best.